So it's been a super week so far, and it's really great to see the level of activity, the diversity of engagement, the sort of spread of ideas that are being presented here this week. The project as a whole, I think, is at a really interesting stage with this shift towards production. I think it's early stages still for production, right? I think it's important for us to get serious pilots and early use cases out there. And learn as fast as possible about OSM in production and shape the project accordingly. Earlier, there was a presentation by one of my colleagues on feedback from some of those initial projects and from members of the ecosystem, looking at all of the sort of questions that are arising from OSM in production. And I wanted to talk today a little bit about how we make those challenges a shared challenge. So if I think about the strategy with OSM, it's really anchored on the idea of having an open source common core effectively that behaves in a consistent way, is standards compliant, and is shared. And then around that, a collection of distributions of that shared platform, right? And you see that here today. You've seen presentations from a number of different actors, each approaching the sector from a different angle, each of which has their own OSM distribution. So I think we can say that the strategy is working, right? Not only are we actually seeing multiple distributions emerge, but you can get a sense of the dynamism that that's driving, right? Innovation, investment, competition. It's a healthy dynamic, and that is great. Digging in a little bit, if we look at what it takes to do OSM really well in production, there are a lot of components and there are a lot of things that have to go just right in order for us all to feel good about OSM, right? We've got all of the components of OSM itself, MBI, LCM, RO, VCA, MonPol, all of the things that support them, right? Kafka, Mongo, MySQL, Prometheus, Grafana, and many other components that every distribution of OSM is going to deploy. Then we have to get those things highly available, right? We have to look at the command and control configuration, not just in the happy scenarios where you're doing the demo and you deploy it and there it's great, it's HA, but in all of the unhappy scenarios as well. When things break, they break in curiously unexpected ways. And every time OSM as a whole breaks, all of us suffer, right? Then you get into the really fancy scenarios, geo-redundancy, and all of the sorts of things that everybody needs to do, backups, and if the worst comes to the worst, disaster recovery. That is a lot of work, and it's all hygiene in the sense that it's not really something that I think anybody wants a distribution to differentiate on, right? It is essentially hygiene, right? If it goes wrong, the brand of OSM suffers, right? Because OSM went down, right? And so I think for me, it's very clear that we're all invested in the idea that all of the distributions do this stuff very well. On top of that, OSM doesn't live in a vacuum, right? It gets integrated with any number of other systems in the operator environment, and it gets deployed in any number of different places, right? Many different implementations of Kubernetes, proxied environments, air-gapped environments. There are a whole bunch of different challenges, and then you have all of these questions of security compliance with different regimes. Again, all of this is hygiene. If all of the distributions of OSM do this consistently well, then OSM gets a great reputation, and there's still room for differentiation at the level of distributions. So this is a key principle for us. Shared open source is very cost effective for everybody. And so the question really is how we can get to shared open source operations of all of those different distributions. And let's take a look at how OSM does it itself, right? OSM has to deal with a bunch of different things in a bunch of different places. It uses packages of operational code, right? The charms, native charms and proxy charms in different environments on Kubernetes or in machine environments as a way to essentially have standardized operations of those components and to provide integration between them. Those charms are embedded in the VNFDs. So inside your VNFD, you've got a bunch of metadata, and then you've got a bunch of operational code as a charm, as a package. And that deals with lifecycle configuration, various operations, day 2 or everyday operations, and integration. If you zoom into that, it's very clear that that's a tarball full of scripts, right? There's nothing too fancy or clever about it. It's a tarball full of scripts. And those scripts are sometimes structured, like the install, config, update, remove, scale scripts. Those are structural. They're inherent in the idea that they're systematic. Every single charm should do all of those things because every piece of software has to go through its life cycle. And then there's integration, which of course depends on what that underlying application gets integrated with, and scripts associated with that integration. And then there are the actions, which in OSM we call primitives, but they're essentially scripts driving daily operations associated with the workload. And so there's a charm of Kafka. It does the life cycle for Kafka, it does integration for Kafka, and it does everyday operations for Kafka. If we look at the OSM architecture, right, you've got all of these OSM components, you've got all of these standard data messaging, integration, coordination capabilities. Then you've got your charms. In R8, we will have the ability to have charms on Kubernetes as well as charms in machines effectively. And all of that has to be glued together, operated in sophisticated ways. So what we're exploring is this simple idea. The VCA is always present, and it does operations and integration very cleanly. So what happens if we use the VCA itself to drive OSM? And so this is a model-driven OSM. These are all the components of OSM and the supporting components represented as charms. So with their operations packaged in the same way that we package operations for the VNFs themselves. And if we do that, then we start to get consistent operations for the components of OSM. So for example, if we want to scale Kafka, then we scale Kafka the same way we would scale a VNF driven by OSM. If we want to run a backup on the MySQL in the OSM, then we do that using exactly the same scripts that we would use to back up MySQL if it was used in a VNFD. If we want to integrate OSM NBI with Nagios, then we can use a relation to model that integration directly. We can drive upgrades and config in exactly the same way. And so if you look in OSM today, if you go look in the DevOps repo, you will find charms of the OSM components. And so that is now a shared collection of OSM operation scripts that can be used across any distributions of OSM that want to use them. And we then have upstream maintenance and collaboration on operations, just like we have upstream maintenance and collaboration on operations technology. And so how does that help with things like high availability? Well, we have K8s, we have LXD. Both of those can be made HA, right? You can scale out both of those. We can then deploy the VCA, which we know is Juju, and scale that out on Kubernetes, so it becomes HA. We can then use that to build out on Kubernetes a charmed OSM model, effectively. Each of those components can be scaled out trivially. Each of those components has its operations packaged with it. Each of those components has integration primitives that allow them to be integrated not just with each other, but with external components as well, using cross-model relations. And of course, everything else is the same. We get our operator instances on LXD where we can put our machine proxy charms. Those can be scaled out as well. As a OSM R8, those will be able to be scaled out, so you can get high availability proxy charms, and you'll get Kubernetes proxy charms as well. So that gives you an architecture for highly available OSM running on Kubernetes, which again, any of the distributions can integrate and drive. Okay, so in this way, we can consolidate knowledge, skill, insights on things like high availability that apply to all of the components of OSM. We also get better integration of OSM with the rest of the world. If you think of a typical deployment, it's not in a vacuum, right? Every operator already has substantial investments in things that they do enterprise-wide at scale. And OSM, to be successful, is going to have to drop into those environments and play nicely with all of those things. And there are going to be multiple permutations and combinations of all of those things. The world is moving away from body-driven integration as a strategy, right? The world of public cloud has taught customers the benefits of pre-integrated components. Now, in this on-prem world, it's very difficult to be pre-integrated because each of those environments is different. But when you look at those environments at scale, you see a lot of duplication. A lot of people will use the same identity systems. A lot of people use the same FCAPs. A lot of people use the same OSS, BSS. A lot of people use similar logging and other systems that OSM is going to need to integrate with. And so while each environment, each operator is a bit of a snowflake, parts of those operators are consistent and reusable. And so while we can't use pre-integrated everything, we can package up integration for reuse, just as we do with the operations of VNFs in our VNFDs. So this allows us now to say, okay, if someone's deploying OSM in an environment where there's LDAP, then we already have the integrations in the charms to just drag and drop integrate with that LDAP. And the same goes for various kinds of FCAPs. The same goes for various kinds of OSS, BSS. The fact that OSM itself is modeled allows us to operate and integrate it to other systems. Now, those systems may not have been deployed in a modeled way, but we can always create proxy charms for them so that on repetitive use of integration of those elements, proxy charms serve as effectively the gateway to those pre-deployed pieces of infrastructure. So this stuff is today in the DevOps repo. You can go and find it there. We are contributing upstream maintenance. Distributions, of course, may use those charms, or they may differentiate the charms. For the record, we, Canonical, do not have any plans to have differentiated charms. Our firm view is that upstream open source is the best place to drive this operations story. And any contributions there enhance that shared operations code base. So I wanted to show you briefly what an installer looks like that uses charms to drive an install of OSM. You'll all be familiar with install osm.sh. There is now a --charmed parameter that you can feed install osm.sh, and that will use those upstream charms to deploy OSM. And so you'll then be using the upstream charms effectively to operate OSM itself. The traditional install osm.sh is a bit of a one-shot thing, right? It stands them up. There isn't really a day two story for that. But when you use --charmed, because you're standing up charms, you have all of the operations that are embedded in those charms for your OSM. You can also pass that installer an existing Kubernetes cluster as a kubeconfig, and then that installer will put those charms on that Kubernetes and configure OSM, the OSM that it deploys on that Kubernetes, to use that Kubernetes. So this flavor of the installer, if you use the --charmed flavor of the installer, you can, and you have a Kubernetes already deployed. If it's HA, that's even better. It will put OSM on that Kubernetes over there. If you pass it a --VCA, then it will use that Juju deployment, that Juju instance. If you have Juju in the building already, it will use that instance as your VCA, right? So essentially you can reuse a Kubernetes, you can reuse a Juju that you already have. You can pass it --LXD, and then you can reuse an existing LXD cluster if you have that. And in development, maybe for R8, although timelines are tight, you'll be able to pass it a --OpenStack and perhaps a --vSphere. So the idea is that you can use this install OSM locally on your laptop and just get a local OSM up and running, Or you can actually use it as a production deployment harness. You can say, okay, there's my highly available Kubernetes, there's my highly available Juju, there's my highly available LXD, there's my highly available OpenStack, there's my highly available vSphere. Now go deploy a highly available OSM on top of all of that infrastructure and use all of that infrastructure. So it's a really neat way to say, get me an OpenStack, an OSM that I can then operate. If you do it on your laptop, --charmed with nothing else, then it'll provide you with a Kubernetes, right? It'll use microgates, which is a single package Kubernetes on your workstation. It'll put Juju on that microgates, just bootstrap Juju on that microgates. There's your VCA. It'll create a model for OSM. It'll deploy OSM on your laptop as a set of charms there. It'll install LXD, if you didn't feed it a --LXD on your laptop. So that your operator instance charms, your machine charms can go over there, and you're off to the races. So essentially on your laptop, you get a little Kubernetes, a little XD, you get charmed OSM, the OSM charms on Kubernetes, and then of course the same Juju that created the model of OSM to operate OSM, you create a new model, you create new models. Sorry, you feed that Juju controller back to OSM, and OSM will create new models for all of your scenarios effectively. That Juju can be multi-user, multi-model, so the same Juju can be driving OSM and driving models of your workloads effectively, your VNFs in your scenarios. Okay, so that installer now unifies the single node experience and a public cloud experience, public or private cloud, and in due course high availability, right? Because we can just scale out all of those components very naturally. Because of the nature of Juju, it's substrate agnostic, so we can evolve that to support bare metal deployments, public cloud deployments, VMware, OpenStack deployments. Those are all just places where models can consume machines. It will handle all OSM and support components, as well as over time, integration with the various OSS, BSS, FCAPS, identity, other systems that we expect people to want to integrate OSM with. And as those integrations essentially land in the upstream charms, everybody benefits from them. And then simplified post-deployment operations. Just wanted to point to some documentation. There is a useful intro to the Python operator framework on the Juju discourse. And then for R8, we plan to document the charmed OSM installation scale, upgrade story, as well as VCA scaling, which I think is a key production criteria. Just to shout out some of the folks that we have been cooperating with. I find this a productive community. It is great to be working with all of you, and thank you for all of the work that we've done together so far. So where does that leave us? What possibilities does that create? We can have a shared common code base and operations code base for OSM, and still have differentiation by different distributions, who will very naturally have reasons why there are things that they're going to do particularly well that very arguably don't belong in that common code base for either OSM itself or operations. And in a sense, the more of them there are still, the better, because then we're getting more shared experience effectively in OSM itself and the operations of OSM. I'll be very happy to take questions now. Titus and Alex are the right people to reach out to at Canonical if you want to explore this idea. And Mona, back to you.